Hello everybody, today we'll be doing find the longest subarray with zero sum. So here we have a array and we have an output of 5. The reason why we have an output of 5 is because we can sum up to 0 with -2, 2, -8, 1, and 7. So that means that as we add items up from the left to right side, if we can find something that sums up to 0, then we are good to go. We can do this in n squared time. The reason being is that we can have n squared different types of arrays. If we go from 15 down to 23 and -2 down to 23 and so on and so forth every single time, that's n squared time, and we'd get all the subarrays. So here we go. Let's check out this one. So we have output of 0 because none were found. Here we have a output of 1 because a 0 was found, and that is our longest subarray. So there are multiple ways of doing this. Another way that we could help ourselves to a faster time is if we use a hash map for this problem. So let's do a match, or should we do some more edge cases? About edge cases, I think we're good to go. This showed up and solved all of our edge cases, and see, yeah, I can't think of any more edge cases at this point. So what we're looking for is a time and space complexity, and I think we're looking at O of 1, n, to go through it once, and a space of O of n to store the items. Right. So let's take a look at a match, and the match is going to be a hash map along with a just a hash map. So how is this hash map going to work? How is this hash map going to help us turn this into a get us the answer for the longest subarray? So let's try to throw in 15 into our hash map. Let's say that's a sum, and let's say 13 is another sum, right? So as you can see, 15 plus -2 is another sum. Let me get those numbers closer to make that more apparent. Then we have, let's say, 15 and plus the -2 and plus the 2, which would give us 15 again. At this point, we can also create a start for a -2. We don't necessarily have to make a 13. So we have a -2 as well. And we have a 2. We started at 2. Here we have a 2 that we apply, and then we see that there's a -2 in here. And we also apply to a 2. Wait, isn't that n squared time? Give me a moment. Yeah, that's n squared, but we found a pretty interesting pattern here. As you can see, 15 and 15 was seen, and that means if we have the index between 0 and 1, 2, we got here suggests that there is a maximum length of 2, because we were at 15 and we got back to 15. That means it must have been a point where we generated a 0 sum. And let's check out the next item. So we subtract 8 from our 15, and that gives us a 7, right? And let's say this has an index of 3. But, and let's keep going. Let's keep going. Let's have an 8 here. And let's have a 15 here. So plus 15, it's total 15. And that means that 4 and 5, we saw our 15 one time here, and another time here at 0. Okay, so that means that we can look for that 15 again, the first time we've seen a 15, and we have a total of 5 length. As we keep going, we have 25, and this is going to be 48. So that's not gonna, we don't any see any 15 or 28 before in this. So that means that we have found ourselves a length of 5. So that's one way. That's our way of finding the length of the longest subarray. So yeah, okay. So let's type in our plan. So create current length, create hash map with length to, value to length, value to index, key equals value, key equals sum, and value equals current index. All right, and what else do we need? We need a max length variable, and we need to iterate through the, what do you call this thing? Array of numbers. Well, what we do when we iterate through these numbers is that we get the current sum, and after we get the current sum, we check, we add to, we check if in our hash map, if in hash map, what we do is that we get the new max length. And how do we do that? What we suggested earlier was to take current index and subtract from found index of the same value. If current sum in, else that means it's not, we haven't seen this sum before. We have not seen the sum before in our hash map. That means we should append to hash map. Add new sum to hash map. Okay, I think that should be it. And yeah, update the max sum. I think that's our last line, 36. So return the max length. Hopefully this works out. I'm not sure if it will. We'll have to find out. So let's move this to the top so that we have space, or better yet, let's move this down just directly below. That way we know for sure. That way everything's in order this time. I've been moving things out of order. Okay, here's the plan. Let's implement. Here's what we got. Let's create a definition. Our definition is called, what's this? length of largest subarray with zero sum. Let's call it largest subarray zero sum. And we're taking an array of ints, and what we're going to return is an int, the largest length. Okay, so according to our plan, let's create a current sum, which is equal to 0. We'll create a hash map, which is equal to a dictionary. And what else do we want? We want to create max length, so our maximum length, and we're ready to iterate, so let's do it. Okay, so for I in range, alright, I think very good. I think we should do an enumerate, because we're just grabbing the value anyways, and let's just save a line. Okay, so what's next? We have a value, we have an integer, we're going to create a hash map. And so current sum plus equals value. If current sum in hash map, then max length is equal to this I minus the the hash map of the current sum. Else, what we're going to do is increment we'll add it into our hash map. So hash map at current sum dot equals our value, which is current sum. And does that, yeah, I think that follows our logic. Okay, with that, I think we are done. Let's return the max length. Let's make a couple tests. I'm going to go get the boilerplate code, and I will come back to you with that. Otherwise, finding me typing out that code would be pretty boring. Hello there, and we are back with our test. It looks like our test did not work out. We have a -10 and a 5. The reason being is that, one, we sent hash map current sum to be current sum, which was not the case. Our language here gave us the wrong impression. Current sum and hash map and index. We should have done that instead. That would have given us a better idea about what we're doing here. And also, one more thing is that our max length changes every time we see that something new. I don't know for sure if that will work every single time. If our newfound max length will be shorter will be longer every single time. That I would do this line of code where we check if the max length is going to be longer or shorter. But from my experience about how we've gone over this code, I think every single time, wait, that's not true. That's not true. So every single time we have done this, it suggests that it would create something longer. But if we think about it for a little longer, what if we found a 13, like right here, or a 7? Let's say we found a 7 right here, right? That would look back and find this particular index and overwrite our 5 with a 6 minus 3, which is 3, right? And if that's the case, we have been overwritten. So this is necessary, this line of code, fix, and this fix, and now we have our the correct output. So suppose, now let's input these solutions here where we don't find anything. We should have a output of 0. So let's add that to our tests and get this going, right? So we have 1, 2, and 3, making sure. and our output of 0. We also have this item here where we have a single 0. Let's check that out. So I think we failed this one because we did not input a 0 into our hash map earlier, and this results in not finding a 0 and resulting in not doing anything when we get that 0. So output should be 1, but we have a 0, okay? And that's not ideal, and we have to fix that. Okay, we found it somehow. Okay, why? How? Yeah, I'm not sure exactly how we were able to do that, but I think we should print a line of code and to see what's going on. Print cur sum. 15, 15, 1. Okay, that's not good. Stop these lines of code. Let's see what's going on here. There was a 1 inside. So we found a 1, 1, and then this is 3. I think we have an error. We have an error. So this is, we put a 1 in, and we found another 1, and that means, oh, that means there's no error. There's no error. That means we found the 1 by using our logic where if we find the same sum before, then we have the difference between those indexes is going to be our value, and the difference between this and this, because there has been no increase in value, that means there must have been a 0, and that means that we have a value that's a true value. There's no problem here. So what do we need to do to improve this? Let's see. I think, can we do this? Is it possible? Or is this... Oh, that's possible. Okay. Great. With that, we have completed our test. We have done our implementation. We have done our review. And what is left for us here is the evaluation. And the evaluation is that we did use O of n space for one loop, a time for one loop. And we also did a O of n space for the hash map. Sorry, with that, we have completed this problem. If you enjoyed this video, like and subscribe. Want more videos, check the link in the description below. And I will see you in the next one. And don't bother. I mean, don't worry. What I'm going to do here is like make a note. Get if find the if no difference in current sum. That means 0 occurred. Okay. With that, I'll see you in the next one. Bye.